An ordinary scale is used to measure the length of an object. This scale is graduated in centimeters, and each centimeter is divided into 10 millimeters. We know that the smallest measure that can be measured accurately with a device is called least count of the device. Since the least count of an ordinary scale is 1 millimeter, it is not useful to measure the length or thickness of an object with great accuracy, that is, less than 1 millimeter. In such cases, a vernier calipers is used. The vernier calipers was invented by Pierre Vernier in the year 1960. It can measure length less than 1 millimeter. Let us calculate the least count of a vernier calipers. A vernier calipers consists of two scales. One is called the main scale or ordinary scale, which is fixed. The main scale is graduated in centimeter and millimeter. The other scale, which slides along the main scale, is called the vernier scale. The vernier scale is graduated in divisions that are less than 1 millimeter. It is designed based on a principle such that n divisions on the vernier scale coincide with n-1 divisions on the main scale. Thus, the least count of the vernier calipers is equal to the difference between the values of one division on the main scale and one division on the vernier scale. That is, least count is equal to 1 MSD minus 1 VSD. The least count of vernier calipers is known as the vernier constant. Let the value of one main scale division be S and the value of one vernier scale division be V. From the principle of the vernier calipers, N into V is equal to n-1 into S. On simplifying, the equation can be written as S minus V is equal to S by N. Since the difference between one main scale division and one vernier scale division is equal to the least count of the vernier calipers, the least count can be written as S minus V, which is equal to S by N. This is equal to the value of one main scale division by the number of vernier scale divisions. Generally, in a standard vernier calipers, 10 vernier scale divisions coincide with 9 main scale divisions. Since the length of each main scale division is 1 millimeter, 10 divisions on the vernier scale are equal to 9 millimeter. Therefore, the value of one vernier scale division is equal to 9 by 10 millimeter, which is equal to 0.9 millimeter. Thus, the least count is equal to 1 millimeter minus 0.9 millimeter, which is equal to 0.1 millimeter. In another way, the least count is equal to one main scale division by the number of vernier scale divisions, which is also equal to 0.1 millimeter. Let us now take a look at the vernier calipers. A vernier calipers consists of a long, thin metallic strip called the main scale. The main scale is graduated in centimeter and millimeter. Each division on the main scale is equal to 1 millimeter. This metallic strip is provided with a jaw, J1, on the lower side at its end, which is called the fixed jaw. A metallic frame on the right side of the fixed jaw slides over the main scale, called the vernier scale. On the bottom edge of this frame is a graduated scale. It usually consists of 10 equal divisions that coincide with 9 main scale divisions. The value of each vernier scale division is equal to 0.9 millimeter. This vernier scale is provided with a jaw, J2, on the lower side which can move with the vernier scale. This jaw is called the movable jaw. The vernier calipers is also provided with two more jaws, J3 and J4, on the upper side. J3 is attached to the main scale and J4 to the vernier scale. A screw S is attached to the main scale. It is used to fix the vernier scale at any position on the main scale. The jaws on the lower side, J1 and J2, are called the external jaws. These jaws can hold the object firmly and help to measure the length of a rod, diameter of a sphere and external diameter of a cylinder, etc. The jaws on the upper side, J3 and J4, are called the internal jaws and are used to measure the internal diameter of a hollow cylinder. A thin and long strip T is attached to the vernier scale at the back of the main scale. This strip is called the tail and is used to measure the depth of hollow cylinders and small beakers. Further, the main scale and the vernier scale are also graduated in inches, which helps in measuring dimensions in inches. Let us now see how the length of an object is measured using the vernier calipers. The object is held by the external jaws of the object, such that the readings on the main scale and the vernier scale are as shown in the figure. From the figure, it is clear that the length of the object is AB. AB can be written as the sum of AC and CB, where AC is the main scale reading, MSR, and CB is the fractional reading, which can be determined with the help of the vernier scale. The fractional reading CB is equal to CD minus BD. Note down the number of the division on the vernier scale that exactly coincides with the definite main scale division. This division is called the vernier coinciding division, VCD. Let this be N. From the figure, CD is equal to N main scale divisions. BD is equal to N vernier scale divisions. Then, CB is equal to N main scale divisions minus N vernier scale divisions. On taking N common, CB can be written as N into 1 main scale division minus 1 vernier scale division. You know that the difference between 1 main scale division and 1 vernier scale division is equal to the least count. Therefore, CB can be written as N into least count. But N is the vernier coinciding division. Therefore, the fractional reading, CB, is equal to vernier coinciding division into least count. The length of the object, AB, is equal to mean scale reading plus fractional reading, which is equal to main scale reading plus vernier coinciding division into least count. Before measuring the length of an object using the vernier calipers, you need to check whether the instrument is error-free. Bring the two external jaws, J1 and J2, in contact. If the 0 on the main scale coincides with the 0 on the vernier scale, then the vernier calipers is free from error. In this condition, the tail of the vernier calipers just touches the end of the main scale strip. If the 0 on the main scale does not coincide with the 0 on the vernier scale, then the vernier calipers is said to have zero error. There are two types of zero errors. They are positive zero error and negative zero error. With the two external jaws in contact, if the zero of the vernier scale is on the right side of the zero of the main scale, then the zero error is said to be positive. The error is equal to the distance between the main scale 0 and the vernier scale 0. The positive zero error is equal to the vernier coinciding division into least count. The correction for a positive zero error is equal to minus of positive zero error. To get the correct reading, the correction should be added to the observed reading. Thus, corrected reading is equal to observed reading plus positive zero correction. For example, when the two external jaws are brought in contact, if zero of vernier scale is on the right side of the zero of the main scale and fourth division on the vernier scale coincides with one of the main scale divisions, and least count of the vernier calipers is 0.1 mm. In this case, the positive zero error is equal to 4 into 0.1 mm, which is equal to 0.4 mm. Thus, the positive zero correction will be minus 0.4 mm. When the two external jaws are in contact, if the zero of the vernier scale is on the left side of the zero of the main scale, then the zero error is said to be negative. The error is equal to the distance between the main scale 0 and the vernier scale 0. The negative zero error is equal to minus of total number of divisions on the vernier scale minus vernier coinciding division into least count. The correction for a negative zero error is minus of negative zero error. To get the correct reading, the correction should be added to the observed reading. Thus, the corrected reading is equal to observed reading plus negative zero correction. For example, when the two external jaws are kept in contact, the zero of the vernier scale is on the left side of the zero of the main scale, and the seventh division on the vernier scale coincides with one of the main scale. The number of divisions on the vernier scale is 10, and the least count of the vernier calipers is 0.1 mm. The negative zero error is equal to minus of 10 minus 7 into 0.1 mm, which is equal to minus 0.3 mm. Then, the positive zero correction is equal to minus of minus 0.3 mm, which is equal to 0.3 mm. Let us now see how to measure the length of a cylindrical rod. First, find the least count, LC, of the vernier calipers. Bring the two external jaws in contact and check the position of 0 on the main scale and the vernier scale to see if there is any error. If there is any error, then note it down and calculate the zero correction. The movable jaw, J2, is moved and the cylindrical rod whose length is to be measured is placed between the two external jaws. Now the vernier scale is fixed by tightening the screw S. Note the reading on the main scale just before the zero of the vernier scale, which gives the main scale reading MSR in centimeter. Note down the division on the vernier scale that coincides with any one of the divisions on the main scale. This gives the vernier coinciding division VCD. Multiply the vernier coinciding division with the least count and convert it into centimeter. The observed reading is equal to main scale reading plus vernier coinciding division into least count. The corrected reading is equal to observed reading plus zero correction. Repeat the procedure by placing the object in different positions along its length. The readings are tabulated as shown. The average of the corrected readings gives the length of the object accurately. To find the inner diameter of a hollow cylinder, fix the cylinder to the internal jaws and follow the same procedure. Similarly, to find the depth of a hollow cylinder or a small beaker, place the tail of the vernier calipers along its depth and follow the same procedure.